In example 5, we're going to go up to density per unit volume. So now we have a compressed liquid that we're fitting into a triangular tank. And we're going to stand this tank different directions and look at the total mass of the liquid for each direction that we can set it. And we have a density function. We know that the density h meters above the bottom of the liquid, so the bottom of the tank, is given by delta h equals 40 times 5 minus h. So we have this linear density function. And first thing we're going to do, okay, let's see, 4 meters long. Okay, so first thing we're going to do is label all these dimensions. So the tank is 4 meters long, and the ends are isosceles triangles with a base of 2 meters and a height, so this height right here, of 2.5 meters. So if we were just trying to find the volume of this thing, even if we were trying to do it by slicing, that's fairly easy. We just need the area of the triangular face, but this is a little different. What we're trying to do now is say if there are 40 times 5 minus h kilograms per cubic meter at a height h meters from the bottom of the tank, can we add up all of those kilograms and find the total mass? Okay, so not uniform density, which means we do have to think about slicing. Because the density is a function of the distance from the bottom of the tank, that's the way we need to slice. We need to make a slice so that everything is about the same distance from the bottom of the tank. So this is going to need to be a horizontal slice that we're making. So when I take my slice out and look at it, it's going to be this triangular cross section with a little bit of volume to it. This is going to be delta H tall, and the base and the height are fixed. So the size of our slice, the volume of our slice, is not changing. Okay, so the volume of my slice is 2 times 2.5, which is 5, delta H cubic meters. So if we multiply meters by meters, and delta H is also in meters, we're going to get cubic meters. That's great, but what we're actually interested in is the mass of our slice. So what do I want to call it? I guess I'll call it big M. The mass of our slice is going to be the density, so the mass per unit volume multiplied by the volume. So at depth h, the mass density is given by 40 minus 5h, and that would be an h sub I for now. So h sub I is how far we are from the bottom. And then this is kilograms per cubic meter. We need to multiply that by the volume in cubic meters so that we end up with the mass in kilograms. So we need to multiply this by a 5 delta H. Okay, so this is working towards answering the question, but we've only found the mass of our one slice, so we're going to want to add up the masses by going from, let's see, oh, well, let's do this first. We're going to have a 200, the 40 times 5. I'm going to move that out in front. And then we're going to have the integral of 5 minus h dh. And we're going to start at 0. This h is the depth, so we're going to start at the bottom of the tank. And we're going to stop at the top of the tank. The tank is 4 meters long, so that'll be 0 to 4. Which means we get 200 times 5h minus h squared over 2 from 0 to 4. Plugging in 0 gives us 0, so we're just going to end up with 200 times 20, let's see, 5 times 4 is 20, minus 4 squared is 16 over 2, so 20 minus 8 is 12, which means we're getting 2,400 kilograms. Okay, so there's a good example. This would be a great time to pause and see if you can work through the different orientations of the tank. So in the next one, we're going to stand it on the tip of the triangle. And then in the last one, we're going to stand it on the base of the triangle. And I think an interesting question to ask yourself is which is going to have the most mass, because the tank stays the same size, always the same volume. So what's going to give us the most mass and what's going to give us the least mass? Okay, so once again, we have density function 40 times 5 minus h kilograms per cubic meter. And since h is still defined, you can ignore the h in this picture. I just stole it from the internet. This is 4 meters, this is 2 meters, and this is 2.5 meters. So h for us has to be how far from the bottom of the tank we are. So our slice now, since we have to do this horizontal slice, our slice is going to look like a little rectangle. And the closer to the top we get, the wider our rectangle gets, but the length doesn't change. And technically there'd be a little slope to some of those edges, but since we're going to make this infinitely skinny, it won't matter. So it's delta H tall. It's always 4 meters long, but the width of our slice is changing. So if we call that, that does not look like a W. If we call that W, we're going to need to do a little sub-problem. Let me draw my triangle a little bigger. So this is 2. This is 2.5. This, I guess we'll just stick with the same color. This little inner triangle is our smaller triangle. Has a height of H and a base of W. So we can say we don't want this extra W in our problem. So the ratio of W to H should equal the ratio of 2 to 2.5, which I'm going to go ahead and bulk up because I don't like the decimal in that. So we get 4/5, and then we multiply by H. So the width is 4/5, here we'll say 4H over 5. Okay, so the volume of our slice is going to be length times width times height, and that's going to be cubic meters. So we're going to get 16/5 H delta H. If we want to turn that into a mass, we're going to have to multiply by our density function. So we're going to have a 40 times 5 minus, and these I guess should still be h sub i's, times 16/5 h sub I delta h. So now we have our cubic meters multiplied by our kilograms per cubic meter, which means we're getting kilograms. We can simplify a little bit. This is a 40. I think I said it. Okay. So we can cancel a 5 out. 8 times 5 is 40. Oh, don't want to do that in my head. Probably. So 16 times 4 is 64. So 16 times 8 should be 128. So it looks like I'm getting 128 times 5 minus h sub I times h sub I times delta h. So if we want the total mass, we're going to integrate. I'm going to go ahead and move the 128 out in front, and I'm going to go ahead and distribute this through as well. We're going to say that's a 5h minus h squared dh from 0 to, this time we're only going to go to 2.5. The depth of the tank is only 2.5 when it's situated this way. So we get 128 times 5/2 h squared minus h cubed over 3 from 0 to 2.5, which is ugly. Let me write it out and then I'll plug it into my calculator. 5/2 times 2.5 is 5/2 as well. So really we have 5/2 cubed. Maybe we can do this without too much struggle. So we have 5/2 cubed minus 1/3 of 5/2 cubed, which means we really have 2/3 of 5/2 cubed, which we could at least cancel the 8 out, but I'm going to go lazy mode on you and not do the arithmetic right now. So we're going to multiply 5/2 cubed, and I get about 1333.33 kilograms. Okay, so notice, what did we get? We got less. I don't know if I think, oh, I do think it makes sense. So the last one was a lot taller, but all that volume up at the top is very low density, so that's not actually contributing as much. This one, since we have that 4-meter long strip at the bottom where it's most dense, oh, wait a minute, it's still counterintuitive to me. I wonder if I lost a factor too. Let's check the last one and we'll see if it makes me feel more like this makes sense. I guess that strip at the bottom is very skinny, so that's probably what it is. Little skinny strip at the bottom, whereas the one up above had that nice flat triangular base. I'm anticipating we should definitely get more from this one since it's we have the highest density at the bottom. The bottom of this one is a lot bigger than the bottom of part B. Okay, so last one, same idea. And again, we already know these. 4 yards, is it meters or yards? Meters. And then 2 yards along the base, and then 2.5 yards tall. So we get this nice rectangular strip. Again, we don't have a choice on h in this problem. H was defined for us. So h is the distance from the bottom. So this will be similar to the last one, but it'll mess with our similar triangles a little bit since the triangle's flipped over. So now we know that this is 2 and this is 2.5, and then we have, that did not work, this little triangle. We're interested in the width of this, and we know that this is 8. Oh, nope, I'm doing it backwards. See, I want it to be like the last one. H has to be from bottom. This is H, which means that the top is 2.5 minus H. So this time we can say that W over 2.5 minus H is equal to 2 over 2.5, which, like we said last time, is 4/5. And then 2.5 is 5/2 minus H. If I'm going to do things without a calculator, I generally would rather have the fractions to deal with. Let's make this bigger so I don't run out of room quite so horribly. Okay, so the volume of this thing is a length, which is 4, times a width, which is 4/5 of 5/2 minus H, times a height. So I'm seeing 16/5, and we could distribute this in. I'm undecided if I think that's better or not. So for now I'm just going to leave it. Okay, so this is cubic meters. We need to multiply that by our density function. So the mass of our slice is 40 times 5 minus h sub I. Put those i's back in. I always want to leave those off. Multiplied by our 16/5 times 5/2 minus h times delta h. And now we have our kilograms per cubic meter multiplied by our cubic meters. So this is just giving us kilograms when we're all said and done. This is the exact same thing we got before. 8 times 16, 64, yep, I think it is 128. And then we have a 5 minus h sub I and a 5/2 minus h sub I delta h. So I'm thinking to integrate, I'm going to want to multiply that out. So I see a 25 over 2 outside minus 5 h minus 5 halves h, so it's 7.5, so it's negative 15 over 2 h sub I plus h sub I squared. And when we go to get total mass, we're going to add all of those up by integrating. So we're going to integrate 25 halves minus 15 halves h plus h squared dh. We're going to start at 0, which is the bottom, and we're going to stop at 2.5. So what do we have? We have 128 times 25 over 2h minus 15 over 4 h squared plus h cubed over 3 from 0 to 2.5. So if we plug in the 2.5, we have 25 over 2 times 5 halves squared. Nope, not squared. Minus 15 over 4. This one is squared. And then we have a 1/3, 5 over 2 cubed. And then we plug in 0, we get 0. Okay, let's see if I can do this carefully. I see 128, and then I'm going to have 25 over 2 times 5 over 2 minus 15 over 4 times 25 over 4 when we square that, plus 1 over 3 times 125 over 8. And I get and what was this? Kilograms. So definitely bigger than the last one. Hold on, let me go back and stare at the first one. It doesn't seem like it should be the biggest to me. Did I lose a factor of, where is it? Right there. Did I lose a 1/2 somewhere? Oh, I think I did actually. I lost a 1/2 in that the area of a triangle is 1/2 base times height. So this should have a 1/2, 2 times 2.5 times delta h, which means this should have a 1/2, which means this is only 100. 1, which means this is 1200. That fits it a little better. What was this one? 16. So the first one had the least. Yeah, I do think I like that better. I was trying to reason it out for myself, but I think with the much bigger length on the bottom, even though it's a skinny little tip, I still think we should add up more. The top of this trough in part A has very little density. So the first one is the least mass, and then the second one, and then the third one. The third one has the most mass. Okay, thanks for watching.